Okay, so it says the distance between points A and B, that's written as AB, is the absolute value of the difference. Okay, so basically what this is saying is, if you took this line, AB, and you wanted to find the distance between those two, it would not matter if you did 2 minus 5.4 or you did 5.4 minus 2. That's what the absolute value accomplishes. Okay, so when we do the absolute value there, you can see that we get absolute value of negative 3.4, or we get the absolute value of 3.4, which the absolute value is just going to turn it positive, right? So 3.4, 3.4. You can think about it this way. If you and I are standing a certain number of steps apart, does it matter if I walk to you forward or backward? Is that going to change the distance we are? If I walk to you forward or backward? It's not. It's still distance, right? 100-meter dash, it doesn't matter if you run forward or backward. You might lose if you run backward, but it doesn't matter, right? You're still running a 100-meter dash, no matter if you're running forward or backward. It doesn't matter if you count from me to you or you to me. It's the same distance, right? Distance is never negative. So that's why we throw the absolute value in there, okay? You will rarely see length, well, I don't want to say rarely, but you will more often than not in this class see congruency statements instead of equality statements. Okay, so you see there on the left it says lengths are equal, AB equals CD. Okay, so AB is equal to CD. More often than not, you will see congruency statements. So you can see the difference between the left and the right. When we write AB, we put the segment indicator above it, right? So that we know it's segment AB is congruent to segment CD. Congruency is just a fancy math word that means equal to, but that's generally how we're going to write it. Okay? So AB, segment AB is congruent to segment CD. Okay? All right, let's talk about the segment addition postulate. It is super easy. Okay? Can I have 3 volunteers? All right, 1, 2, 3. All right, you guys all just stand up in a line up in the front. Yeah, you were part of that 1, 2, 3. Only 3 people raised their hand. Okay. All right, so Joe, I remember your name.
There's 3 of them.
Well, thank you. Oh, yeah, Olivia. Oh, that's what you were saying. Olivia. No, I don't. What? Ethan. Okay, so Joe, Olivia, and Ethan. Okay, so Joe and Ethan, I want you guys to say the same distance apart. Okay? That distance is not going to change. Olivia, I want you to just take a couple steps over towards Joe. Okay. Did the distance between Joe and Ethan change? No. So the distance between Joe and Olivia plus the distance from Olivia to Ethan is staying the same, or is changing, right? But the distance, if you add them up, if you add them together, that's never going to change, right? So regardless of where Olivia is between those two, the distance from Joe to Ethan is not going to change. That's what the segment addition postulate is. All right, you guys can go ahead and sit down. So no matter what AB and BC, no matter how AB and BC change, if B's in the middle, AC is not going to change, right? That's what it's saying here. No matter what this B value is, wherever it moves in between A and C, AC is always going to be the sum of the parts, AB plus BC. So you can think about it that way. The whole is the sum of the parts. Okay, the whole is the sum of the parts. All right, so let's look at the next page and actually practice. All right, so I'm going to give you some time to go ahead and plot the points on 1, 2, and 3. Yes, you will have to make your own X and Y axis on each of those graphs. Then plot your points. I want you to see if AB is congruent to CD. Okay? All right, I'll give you guys some time to do that together with your groups. Go ahead. Okay, guys, let's look at 1 and 2 really quick. Okay, so you can see on my plotted points there, the distance between A and B is 1, 2, 3. The distance between CD is 1, 2, 3. Does it matter that AB goes left to right and CD goes right to left? No, that's how that absolute value thing works when we look at it algebraically. Okay, so AB and BC are congruent. So writing my congruency statement, segment AB is congruent to segment CD. Okay? All right, number 2, it looks like AB is 1, 2, 3. CD is 1, 2, 3, 4, 5. So those would not be congruent. So I would say AB, segment AB is not congruent. So just a slash through it to segment CD. Okay? So we know about congruency. Now let's practice our postulate. Okay? So go ahead and try all 4 of the rest of them. 4, 5, 6, and 7. So make sure you, it's going to be easiest on you to draw a picture for number 7. Also make sure on number 5, don't stop with finding X. Answer the question they ask you. You will find most times in this class, the first quote-unquote answer you arrive at is not the final answer. Make sure you answer the question they ask. Okay? All right, go ahead and do 5 through 7. All right, guys, let's look at 4. Forgot to record. All right. So the parts should add up to be the whole, right? So if I take my 31 total, oh, get the pen out. My 31 total, that should add up to this VW part plus 8. Yeah, the recording can hear me. And you.
Okay.
You want to say hi?
No.
Okay. All right, so we subtract 8 from both sides. Subtract, oh my gosh, that's an ugly 8. Subtract 8 from both sides, and I end up with what, 23? Okay. All right, let's look at 5. 5's the tough one. Okay. All right, so the parts should add up to the whole, right? So x plus 3 plus 2x plus, oh, why did I say 3 and wrote x? Ooh, end of the day troubles. All right, plus 2x plus 6 should equal the whole, so 10x minus 12. Okay, so brush up on your algebra skills and solve this. So on the same side, I want to combine like terms. So I have x plus 2x, that makes 3x. A 3 and a 6 makes plus 9. Okay, I have simplified. Now I'm ready to solve. Remember, anytime you go across the equal sign, you want to make sure and do opposite operations. So I'm going to subtract my 3x over to this side. I'll just do it all in one step if that's okay with you guys. Add 12 over to this side. That's gone. I'm left with 21. I'm left with 7x, and that's gone. So I should divide by 7, and I end up with x is 3. Is x is 3 the answer? No, so that's what I kind of prepped you guys on a little bit, right? The question doesn't ask us what is x. The question asks what is VW. So VW is this piece right here. So I need to do one more step. So 2, we just figured out x is 3 plus 6. So 6 plus 6 is 12. That is my final answer. Did it freeze? It froze. Okay, and then last but not least, the application problem. Okay, so you're at a bookstore, a bookstore and movie theater are 6 kilometers apart. So let's draw my picture. I'll do my B from my bookstore. Over here is, what is it? Movie theater. So movie theater. Okay, and that's 6. This is 6 right here, right? The whole thing is 6. A florist is located between them. That is 2.5 kilometers from the movie theater. Okay, so here's the florist. This is 2.5. So the sum is the part of the whole, or the whole is the sum of the parts. Easy for me to say. Okay, so I need to find this area, or this space right here. I'll call that x. So 6, my total, should equal x plus 2.5. So subtract 2.5 from both sides, and you get 3.5 kilometers. Okay, so that means that the florist is 3.5 kilometers from the bookstore. Okay.